Okay, we're back in the shop, and today, as I promised you, we're going to take a shot at making one of these brooches here, which is what this drawing is for. This is the first one that I made. I actually made two of these, but they came out in different hardness, so I'm going to show you what I do and how I do it, and you guys can take it from there. This will be a 1/4 inch hex bit. The drawing kind of shows the length of this to the shoulder is 0.625, overall length 2 inches, and it's 1/2 inch diameter W1 water hardening drill rod. So we're going to create this blank to start from. So when we start with this, is this going to have a square shoulder like this. And this will be turned cylindrical, and we'll do that in the lathe, and then we'll take that piece and go to the vertical mill and mill these flats out using carbide end mill. So I'll get set up and I'll bring you back. Thanks. Okay, we're at the lathe and we're all set up and ready to roll. What we're going to do is turn this back, let's see, to 6250 on a square shoulder, and we're going to turn that stub down about a 0.320, and that'll give us around 15 thousandths per side extra when we start the milling process at the mill. So start the rotary phase changer and then we'll get going. All right. I'm going to touch off here and set the DRO. Missed it. Try that again. Okay, here we go. Take a good cut here. Bring this out to 0.60, and then we'll keep turning, and then we'll finish up at 0.625. Okay, we're going to get the size. There's our 320. Now we're going to go to 62. And that's it. There's our blank. That's what we're going to start with. All right, so I'll get set up on the mill and I'll bring you back for that. Okay, we're all set up on the mill, and we have a 2-degree angle block underneath the rotary indexer sitting on a stack of parallels just to get that angle. So now that I've got that set, I'll pull that out and show you what that looks like. Just a little angle block, and that's all you do is kick that up like this, and now that's pointing downhill by 2 degrees, so we'll have a 4-degree included angle on every cut we make on there. So I'll get rid of the angle blocks since we don't need those right now, and the parallels as well. Next thing we're going to do is find the center of this stub and the end, and then we'll put a 1/2-inch end mill in there and start making cuts. All right, so here we go. Yeah, we're about the same thing. So I think we're good. Might as well do the X. All right. Now for the cut, I like to use a nice sharp carbide end mill, preferably a new one that's not been chewed up. And you'll be amazed at the finish you get when you got a nice new mill in there. All right, we got that nice and tight. We'll turn on our Z-axis DRO. And the trick here is to make one cut, get a suitable flat, get a reading off it, and that'll establish the radius of your cut, and then you can set your DRO precisely. So that's what we're going to do here. So right now I'm just setting my rotary index to 0 so that I can do that indexing. And then I'll come down on the mill just to touch off. Okay, so there we go. And now I'll take off. I'll set a 0 and we'll take off, oh, maybe 10 thou. Lock the quill. And we come into 0.625 would be the shoulder. go. There's one cut. Now we're going to index the opposite side, which would be 18. And same thing. Get another 0 on the z-axis, and we'll let the quill go up. At this point we can turn it, and what we're looking to do is measure those flats, see what we got there. Now this is a little tricky because you can, if you're not at the right angle and your micrometer's not on the center line, you got to kind of feel it. So it looks like we got 2936. All right, now let's cross the flats. Since we're working on a radius, we want to take that 0.2936 and divide that by 2. That gives us 1468. So we bring our quill back down to our 0 on the z-axis. All right, and at that point there, I'm going to set this DRO for the z-axis to 0.1468. We'll call that 147. 1465, close enough. All right, at this point here, we need to, since we're going to melt the 0.2525, that's the width we want on that hex broach. I'm going to divide that by 2, and that means I got to get to 126, and that should give me a flat that is 1/4 inch on the money. So back to 0 on the index. And we're going to go down to we'll go down to 130. And then we'll take another measurement just to make sure we didn't mess anything up. Now this W1 drill rod is in the fully annealed state, so it machines like butter. There's 62.5. And we'll shut off the mill. Rotate around so we can get a measurement. Okay, so I've got 2609. Which would be if you multiply our 130, we're at 260 and 9/10. So we're in pretty good shape. So we're going to continue. Come down to we got to go to 126.2. So we're going to go to call it 127. Lock our quill. Come back to our 0. And right up to the shoulder, 625. There we are, that's one flat. Rotate 180. Come up to 625 again. There's our 625. And we'll rotate sideways. Take another measurement. And that should be darn close to 2525. We got 253. So I'm going to leave that on there, because when we're done, 253 is what I got across there. 25325. Take another look at that. I don't know if you guys can see the mic on the, probably not. There you go, 2532. All right. We're going to complete this, and then when we're done, we're going to go to the surface grinder and bring that back until we get to 2525. That's the way to do it. All right, so now we just keep going all the way around. Our next point is 60 degrees. taking my time when I get near the shoulder. It goes slow. You can kind of hear the mill hitting the shoulder now. And that's 6250. Yeah, we'll go to our next index, which is 180 degrees, which we already did, so we can skip that one. Now we're going to 24, 240. That's 6250 on the DRO. And the next one is 30. There's 6250. And then back to 0. Which is our last one. So now we've completed the broach. We've got a nice hex milled off. Let me get the camera off the tripod here. And let's get that out of the way. See if I can give you a shot on the end here. Bear with me. We've got a nice completed hex. And you can see the finish on that. It's pretty doggone nice. Let me get in focus here. Alright, now this part here, we're going to put that chamfer on in the lathe. So now we've got a length of 6250. We've got a side-to-side dimension of 253 and a half, somewhere around there. And we're going to harden this thing on the very end at the tip here. And then we'll mount that in the surface grinder and just go across that tip and bring her down a size. The commercial ones, I did a little research, and they're at 2525 across the flats. I'm assuming they want a little bit there to allow you to resharpen over time, but once you get past that 250 point, then you're going to be undersized, and you don't want that. So I'm going to get set up back on the lathe, and we'll do that part. Okay, we're back at the lathe, and I'll kind of bring this down a little bit. And what we're going to do now is put that little chamfer on the end of the tool bit. And I'm just using a TCMT tool bit and creating that chamfer. And now I'm going to pull back. Now I want to stop the lathe and check to see my clearance. Looks like I got a little more to go. Now we don't want to get a cut into those flutes that we just made. We just want to create that cute little chamfer. It gives us a little clearance when we're using the tool. get a little bit more to go. This is more of a how do you like it kind of thing. I think that's good. Now that completes everything we wanted to do on that, except for that little divot on the end to allow for a little bit of chip clearance. So the way I've done that is with a 1/4 inch ball nose end mill, and we'll do that next. Now when you do that little divot in there, you really don't want to go too close to the flats because that'll weaken the flats. You just want to put a little pocket in there that allows the chips to go somewhere. But you really don't have a lot of room in there to begin with, so when you're doing a blind hole, you really have to go in and out of the hole because the chips are going to pack up at the bottom of the hole. Especially on like a custom, like an oil plug with a hex in there or something like that. You're going to be going down into a blind hole. So again, this is another one of these things where you eyeball and everything. So here we go. A little more to go. Yeah, that's how I like it. Just a little bit of a pocket in there for chips, but the sides are going to stay flat and they're fairly wide, so they'll be strong enough to handle like a 1018 steel or something, maybe even a little harder once it's hardened. So that completes it. All we got to do now is pull the end out and cut it to a 2-inch length. A little trick that I picked up from Joe Pye, if you guys watch his channel. Excellent machinist and a lot of neat tips and tricks for you guys that are just starting out. Catching the edge of that cutoff tool with a little right there. Okay, so now we'll set our DRO. Set Got a 0 on our Z-axis. Pull our tool out, come up to 2 inches. And we'll give us ourselves, maybe 5 thou for a little trim cut. A W1 drill rod in this state really machines nice. There you go. While we're at it, clean that up for the next time. Okay, that takes care of that. Now all we need to do is put a little chamfer on the back side of our tool, clean up the end. There you have it. See if I can get you a picture here without being all blurry. So you can see the finish on those flutes. It's just absolutely gorgeous. Those carbide end mills, good quality carbide end mill. If you're paying around $40 for a carbide end mill, you probably have a pretty good one. If you're paying less than that, you probably got the cheaper ones. And there's the end bit that I was talking about. You see that little divot there. Now the commercial ones have some kind of like a triangular shape that comes from the corners of the hex going into the center. I haven't figured out how they make that. I'm assuming it's either forged that way, or I don't know how they make it. But anyway, we've got ourselves a blank ready for heat treating, and that'll be the next piece. So catch you later.